Okay, so section 5.2, and section 5.2 is going to be the inverse of cosecant, cotangent, and secant. But before we get started, I want you to pause this video and get your book, page 308. Alright, so at the top of page 308, you're going to see a pink box. Now that pink box has the natural restrictions for cotangent, secant, and cosecant in it. What are natural restrictions? Well, remember, with sine, cosine, and tangent, we had to have restrictions on the domain so that it was a one-to-one function so that we could find an inverse. Same thing here. These are the natural restrictions. We just didn't draw them out and show them to you like I did for sine, cosine, and tangent. And if you look in the yellow box, these are all the inverses of cotangent, secant, and cosecant with their domains and all those sorts of things in their graphs. Now, you're not going to be asked to draw these things a lot. The main thing you will be asked to do is to be able to solve problems with them, be able to use them. I will provide the information at the top of the yellow box to you on your formula sheet for test for your exam. You'll need to know the pink box. Okay, so let's look at an example so we can see how to apply this. So arc cotangent of -1. So this is where cotangent of y equals -1. And remember, it's -1 over 1. So cotangent is x over y. Now we'll need that when we get ready to draw a triangle here in just a second. So remember, our restriction for this particular inverse is 0 to pi. So what angle, the cotangent of what angle in 0 to pi equals -1? That's basically what you've got to ask yourself. So let's draw our reference triangle. Now, this is -1, 1. And if you use the Pythagorean theorem, that's going to give you square root of 2 there. Now, here's what you got to be careful with. This right here is not y. That's your reference angle. Okay? And the other ones, it happened to be the reference angle. But it's not for this one. Because it would not be in our 0 to pi range. Our reference angle here is going to be this. Our angle we're solving for here is going to be this. This is angle y. Okay? This is angle y. So, because remember, we're starting from 0 when we take that angle. So, what is this point here? Well, this is the point -1 over the square root of 2, 1 over the square root of 2. So relate that back to your unit circle. What angle in our unit circle gives us that? Well, the angle that gives us that is 3 pi over 4. And 3 pi over 4 is between 0 and pi. So what we can say here, and I wrote this wrong, it should be the arc cotangent of -1 equals. What we can say here is that the arc cotangent of -1 is 3 pi over 4. Alright, so let's look at another example. This time, let's look at the inverse secant of 2 over the square root of 3. So this is where secant y equals 2 over the square root of 3. Now remember what secant y happens to be. That's r, our hypotenuse, over x. R over x. So when you get ready to draw your reference triangle, that would be square root of 3, and 2. And of course this would be 1 if you used your Pythagorean theorem. Now, what's the secant of what angle is 2 square over the square root of 3? Now, this is angle y. Why? Because we are moving from 0 standard position up, remember. This other reference triangle, remember, when you draw reference triangles, you always draw them down to the x-axis. So when we drew the one up here down to the x-axis, this particular reference triangle, this was not angle y, this is angle y. But we had to draw our reference triangle down. Now this is still angle y, and it's contained in our reference triangle. So that's the difference in those two problems. One contains angle y, one does not, just because of the way you draw your reference triangle. Okay? So, what we have is this. So this is the point square root of 3 over 2, 1/2. So what angle on your unit circle gives you that? Well, that's pi over 6. So we can say that this answer is pi over 6. And pi over 6 is between 0 and pi. Is between 0 and pi. So, because notice what it says, and I didn't pay attention, I didn't call attention to this at first, but it didn't really matter, that's why. But this is our restriction for this particular problem. Notice it's different. Up here it's 0 to pi, but we don't touch 0, we don't touch pi. Here we do, but notice there's a little extra on this restriction. Y will not equal pi over 2. Okay, so pi over 6 is not pi over 2, and it's between 0 and pi, so it's a viable answer. It's a viable answer. Okay, so this is how I want you to be able to use that chart in yellow to solve problems kind of like that. Alright, so let's look at a more in-depth problem. Okay, so the tangent of the inverse secant of -3. Alright, well, let's let y equal the inverse secant of -3. So secant y has to equal -3 over 1. And remember, secant is r over x. So if we draw our reference triangle, it should look like this. This is going to be, this should be +3 over -1. A little minor mistake there. Why is that the case? Why should this not be negative? Because r will never be negative, remember. R will never be negative. It's just x and y that are negative. So this would be 3, -1. And if you do your Pythagorean theorem, you can find this side very easily as 2 square roots of 2. Now, again, because of the way this is drawn, this is our reference angle. This is not angle y. Remember, angle y is right here. So here's where you've got to be careful. So now take this, and we're substituting in. So really what we're trying to find is the tangent of y. The tangent of y here. Okay, so now this is the point. This is the point. If you're looking in terms of, since we're in tangent, we're looking in terms of sine and cosine. This is the point -1 over 3, and this is the point 2 square roots of 2 over 3. So remember, tangent is sine over cosine, or y over x. So this is going to be 2 square roots of 2 over 3 divided by negative 1 over 3, which gives you 2 square roots of 2 over negative 1, which gives you a negative 2 square roots of 2. So we took our inverse, used it to get our reference angle and our triangle set up, and then we used it to find the tangent, okay? Just like we've done in previous sections, okay? So that's nothing different. So don't let the secant fool you. It's just a different way of having to do the reference angle, triangle. Now, I haven't spent much time on calculator stuff. I typically don't. But I will tell you this. Now, we get in the hang of writing, when we get ready to type in the calculator, we get in the hang of, if I were to ask you to type secant at the calculator, you're going to type it in as 1 over cosine. Well, and you're going to type cosecant as 1 over sine, and cotangent is 1 over tangent. So it's very tempting to do that with the inverses. It's very tempting to write this inverse as 1 over the inverse cosine. That's not true. You can't do that. Okay? So look on page 311 in the pink box. And the pink box will show you the identities for being able to use your calculator. Now, if you like using the calculator, and you're going to need to be able to use the calculator with this is where you're going to need to be able to remember these, okay? So, let's look at the bottom part here. Let's look at letter A on that same page. And it asks you to find the inverse cotangent of 4.05. Now, we're doing this with a calculator, so if you look in that pink box at inverse cotangent, now notice it says x greater than 0, x less than 0. Well, 4.05 is obviously greater than 0. So you're going to follow this guideline. This is how we're going to type it in the calculator. So our x here happens to be 4.05. So in your calculator, you're going to type the arc tangent. You should have one of those buttons on there, of 1 divided by 4.05. Now make sure your calculator's in radian mode when you do that, and you should get 0.242 as it says there in your book. So you've got to be able to remember this to type it in correctly so you can get these inverses. What about the inverse cosecant of negative 12? Well, if you look at inverse cosecant, it uses the same one, but notice x has to be greater than or equal to 1 or less than or equal to 0. So if x is between 1 and negative 1, then you've got a problem. You're not going to be able to type it in the calculator there. So it's the inverse sine of 1 over x, which in this case would be the inverse sine of 1 over negative 12. And because you have it in radian mode, it's going to give you 0.083. Alright, be able to do the same thing if you look at letter C. That's the inverse cotangent of negative 0.24. So notice x is negative now. Look at your x. X is negative. So we're going to use this formula to type in the calculator. You got pi plus the inverse tangent of 1 over x. So this is going to be pi plus the inverse tangent of 1 over negative 0.24. And so punch that in your calculator, and you should get 1.806 if you do that correctly. So there are some things you are going to have to be able to do in your calculator that you're going to have to know these formulas to be able to do them. And arc cotangent, arc secant, arc cosecant are the ones that you're going to have to be able to do that on, okay? The rest of them, it's not really going to matter. Alright, so, last but not least, out of section 5.2. Excuse me, sorry about that. Is this right here. If I want you to find the secant of the arc cosecant of x, and I want you to write this in terms of x, okay? Write in terms of x. So I'm going to let y equal the arc cosecant of x, which has a restriction of negative pi over 2 to pi over 2. Okay? So this is the cosecant of y equals x, or x over 1. And remember, cosecant, this is going to be r over y. Alright, so now here's the part with arc cosecant that you've got to be very careful on. Okay? Now, because it's between negative pi over 2 and pi over 2, there are two possible reference angles for y. One in quadrant 1 if x is greater than or equal to 1, and one in quadrant 4 if x is less than or equal to 1. If you look back at your graph on page 308 and you look at cosecant, okay, you'll see what I mean. There's going to be two possible choices for that between 1 and negative 1. Notice how the graph starts at 1 and is greater than 1, or it starts at negative 1 and is less than negative 1. So you've got to be prepared for both of those. So here's what we have. When we get ready to draw a reference triangle, we have to draw it. This is x and 1, and let's just call this A for right now. Now, the other one is where x is less than negative 1, which is going to be, because this is negative pi over 2 to pi over 2, it's going to be in quadrant 4. Negative 1, A, and negative x. You have to include that because x could also be negative x divided by negative 1. See what I'm saying? So two negatives make a positive, when you divide, make a positive, just like two positives do. So with this particular graph, you have to take both of them into consideration. So in either case, what we say is we say r being the hypotenuse is the absolute value of x. Because remember, r can't be negative. So it's the absolute value of these two, because that'll always give you a positive. Now, in either case, if you take the Pythagorean theorem and solve for a, this is what you get. In both cases, that's what you're going to get for a. So, now, because we know that, we can figure out very easily what the secant of y equals, because that's our goal. We're going to substitute y in right here. We already have our two reference triangles. So what is secant? Well, remember, secant is the same thing as r over x. That is what secant equals. Okay? So in this case, it's going to be r over a. A is our x value here. Okay? A is our x value in both of these. So in order to accommodate both of these so that we don't have to write two separate answers here, we're going to use the absolute value of x for r, because that takes both x and negative x into consideration, and a is the same for both of them. So we have the square root of x squared minus 1. Square root of x squared minus 1. Again, these formulas will come in much more handy for calculus. Just be able to have a general idea of how you solved them. How did we know they were How did we know there were going to be two reference triangles? That's typically the question. Well, that's because if you look at your secant graph, you've got one part of your graph that's 1 and above, one part of your graph that's -1 and below. Okay, and since we're from -pi/2 to pi/2, that means you got to have 1 in the first quadrant, 1 in the second quadrant. Okay, in order to accommodate both of these answers. Okay, hopefully that makes sense to you. Section 5.2 and 5.3 will be done shortly.